Hello and welcome to this tutorial video. My name is Clark Jarvis and I'm a technical marketer engineer at Infineon Technologies. In this video we're going to walk through the basic getting started steps associated with running Zephyr on an Infineon PSOC 6 development kit. The getting started steps for Zephyr are well documented on zephyrproject.org, but there are a few extra steps required for the PSOC 6 development kit. And it's always helpful to see the process in action, so you know what to expect. This entire process took me about 30 minutes to complete, but it will vary depending on the speed of your computer and internet access. For this video, I've sped up the playback in several places, so you don't have to sit through the time it took to download and install something lengthy. To get started, I'll open up my web browser and navigate to zephyrproject.org. From the Technical Resources menu item, we can access the documentation webpage, which includes a Getting Started Guide link. This online guide will guide us through setting up the command line Zephyr development environment, getting the latest source code, and building and flashing a sample application. Details are available for Ubuntu, macOS, and Windows. The installation on Ubuntu is very straightforward, and I've been able to easily set up Zephyr on a native Ubuntu machine or with a VM, and I recommend using Ubuntu as possible. But for this video, I'll walk through the steps using Windows, as there are a large number of users working with the Windows operating system. Our first step will be to install all of the dependent applications. This will include applications like CMake, Python, and others. You can install these directly, just make sure you're using the detailed minimum versions. But to make installation a bit easier, the Getting Started Guide includes commands that are leveraging Chocolatey to install the needed applications. Selecting the Install Chocolatey link will open a new browser tab with these additional steps. Navigating down to Install Chocolatey for individual use, we can follow the recommended steps. First, we need to use a command shell with administrative rights, and the steps shown on this page are meant for PowerShell. So I'll open up PowerShell from the Windows Start menu, and by right-clicking on the application, we can choose Run as Administrator. From here, we can copy the command details on the page and paste directly into PowerShell console. This command will download and install Chocolatey. Once complete, we can confirm that it has been installed using the command choco /?. This will display the help content for Chocolatey, verifying that it is installed. We can now close this window and return to the Zephyr page. The next step also requires that we use a command line console with administrative rights, but specifically request that we use Windows Command Prompt, as the required commands would be slightly different in PowerShell. Using the Windows Start menu, I'll type in CMD, and to find the command prompt and right-clicking, select Run as Administrator. This step will leverage the Chocolatey commands to install a number of applications. First, we'll disable global confirmation to streamline the installation process a bit. And next, we'll install the required application. Copying these two lines will install CMake, as well as Ninja, gperf, Python, Git, Devicetree, wget, and 7-zip. These steps can take several minutes, so I'll speed up the video. Note you'll likely need to press Enter within the command console to accept the last command. At least this was true for me anytime I copied multi-line commands from Chrome into the console terminal. Once the installation steps complete, we see that a number of applications have been installed. At this point, I would highly recommend restarting your computer. The steps detailed in the Zephyr Getting Started Guide don't call this out, but I found that many of the programs particularly Python and West, just did not work correctly until after a full Windows restart. Now, with Windows restarted, we can return to the Getting Started guide to complete the next steps. Making sure that the Windows tab is selected, we can scroll down to the Get Zephyr and Install Python dependencies. We will also run the next set of instructions in the Command Console prompt, but this time as a regular user. The guide recommends installing a virtual environment. This will help ensure that you're using the expected versions of Python in Zephyr, and generally I've had much more success working within a virtual environment. The first step will create the virtual environment for us inside a Zephyr project directory. Since we are using the Windows command prompt, we will copy this specific command to activate our virtual environment. After running the script, we see our prompt is now prefixed with a .venv, indicating that we're working within the virtual environment that we created previously. And whenever we need to return to working with this installation of Zephyr, we will need to reactivate the virtual environment. All right, our next step will download and install the West command line tool used by Zephyr. With West installed, we can initialize our working directory and call West update to download the needed Zephyr source code. This step took about 10 minutes on my machine, but through the magic of video editing, we can skip ahead to the next step. The West Zephyr export command will update or add the needed registry entries to allow CMake to load the proper Zephyr code. And here we're using Python to install additional dependencies as detailed in the downloaded requirements.txt file for this version of Zephyr. A few minutes later, we now have all the required applications installed on our Windows system and can install the latest Zephyr SDK, which provides the needed toolchains and programs to build an embedded Zephyr application. In addition to the SDK, we will need to install some Infineon-specific resources and programs, but we'll cover that in a bit. The SDK installation can be done in a different command console, but for this recording, I just used the same one that I already had opened. I'll first clear the console so that we can focus on these specific steps. Navigating back to our home directory, we'll use the wget to download the latest Zephyr SDK bundle release. Once the download is complete, we can use the 7-zip command to extract the SDK folder and files to our home directory. Navigating into the extracted SDK directory, not the Zephyr project workspace directory, but the Zephyr SDK directory, we can use the provided .cmd script to set up and register this SDK. The next steps in the Getting Started guide are to build a sample application, but there are some additional steps that I mentioned that we need to complete first, since we're working with the PSOC 6 prototyping kit. And these additional steps are documented on the supported board page for the PSOC 6 kit. We can find this page by navigating to the top menu bar and selecting the supported boards menu entry. There are hundreds of boards supported by Zephyr, so I'll use the Control F to search for the term Infineon. From these results, I'll select the Infineon CY8C Proto 0624343W board. The resulting page will provide an overview of the prototyping kit and which features are supported within Zephyr. Let me quickly clear the console screen again and we can complete the steps required to use this board with Zephyr. Our first additional step is to install the Infineon source files using the provided west command. This command should be run from the Zephyr project directory. And now that we have these additional files available, we have everything needed to build a Zephyr application for the PSOC 6 Wi-Fi Bluetooth prototyping kit. Copying and pasting in the next set of commands will navigate into the Zephyr subdirectory and call the west command to build an application for the -B CY8C proto _062_4343W board. The sample application that we'll be building is the samples/basic/Blinky demo. Note there is a typo here. A Y needs to be added to make this Blinky. The very first time you compile Zephyr will be quite a bit longer than subsequent builds, so we'll jump ahead to the end of the build process. And now we can turn our attention to programming the application to our board. The PSOC 6 prototyping kit features an onboard KitProg debugger. This debugger works with a custom build of OpenOCD that is provided by Infineon. Currently, this OpenOCD package must be installed separately from Zephyr. At the time of this recording, the instructions recommend downloading and installing Modus Toolbox to obtain the latest release of Infineon's OpenOCD package. Alternatively, you can find the OpenOCD binary on Infineon's GitHub page. Go to github.com/Infineon/OpenOCD and select the latest release for the available binary file. On this Windows machine, I happen to already have Modus Toolbox installed, so I'll use that instance of OpenOCD in my west flash command. To program the Blinky application to the board, I'll type in west flash --OpenOCD. The default path for the OpenOCD binary from Modus Toolbox is C:/users/ and then the name of your account /Modus Toolbox /tools_3.1. In my case, that's the latest version I have installed, /openocd/bin/openocd.exe. If you download it directly from GitHub, it will be in whatever directory you extracted the contents of the zip file. For Infineon boards, you must specify the use of the Infineon version of OpenOCD. The stock version available from Zephyr or from openocd.org will not work. With the board connected via a USB cable, pressing enter will now program the most recently built Zephyr application, in our case Blinky, to the board. We should now be able to see the LED on the prototyping kit blink, as shown in the video window. From here, you can refer to additional sample applications or start creating your own application. Look for more details in the documentation section of zephyrproject.org. Thank you for watching.